up to the cutoff right around 400 hertz to where it goes on solid. The anode load spark gap doesn't fire. When I get the frequency up to 600, we start to see nodal points in this. Now, and I don't think these are obviously not 600 hertz nodes because the tube ain't long enough. These, I think, are something else. But look at the separation that occurs. We go real high. Let's see if we can get on the next. This is times 100 now, so. This is a UV tube, by the way. It's out of a air ionizer. And I don't think the tubes respond much more past that point, but we'll go back down to 400, 600 here. Yeah, wait to see what this looks like in the nighttime. Still got too much daylight here. I'm going to vary the millivolt input. This is the signal input, so you can see the wave direction changing based on the input amplitude of millivolts. And then when it's high enough, they become much more defined. Nodules defined. We'll get back here to just very low input, controlling the signal into this amp, so I'm not getting a lot of distortion because of that. Then we get some intermittency from this spark gap that's actually diagonal on this side of the capacitor and that side of the other capacitor, so that's how it's behaving. And so it intermittently fires, but can I focus on that? Apparently not. Oh well. The other one's not. Just barely firing. So this is directly across the anode. So what we're seeing here is like the only voltage here is the resistance of the what do you call it? Cathode to plate voltage drop that exists. So we go all the way down to 1 and turn. It takes a lot more power on damn it, times 10 to get it going here. But you can see this one, it's down to about 30 hertz right now. We can see just a little bit of activity in there. Bring it up to like 60. Get some intermittency with until we get up in full. That's the top of the times 1. So you can see an amplitude modulation in the luminescence, in a sense, because the wave gets higher and gets thicker and smaller. So there's dead points that you can see in it that go on to form the nodes when it finally does stabilize. So right as the beat stops happening, right at 510 hertz, we start to lose all the harmonics and it just goes on full. See if we can go from here to right there, that click on. Right now it's on 500 hertz. At about 510 it goes full, and the other spark gap stops really doing much. And then we start to see the nodal points coming in. And they don't seem to like change in their spacing, so that's what makes me think this is more of a beat frequency effect. But the beat is actually much higher frequency than the incident frequency in this case, which is 1200 hertz about. And that's what's weird, because right before we see the beat here as a dropout, almost, and then once we hit unity, when the two guitar strings are in tune, it's real sharp. It kicks on. So pretty cool, huh? Bidirectional simultaneous opposing current flows on the same wire, separated magnetically in the same spark gap. And now we're driving that transformer just because I needed a little bit better primary load. This thing works a lot more reliably with the primary load, and there's much more voltage output, obviously, because my primary before sucked. But cool, huh? Let's see what else we can hook up to it.